Good morning, dear students. Welcome again. Today I am going to revise your second lesson, that is called solutions. In this lesson, first I recap the definition of solution, characteristic of solutions, different types of solution, how you can form. So first of all, we see the true definition of solution. When two or more chemically non-reacting substances are mixed together, forming homogeneous mixture. The mixture is called solution. Some important points regarding solutions. The first one, a solution consists of single phase, that is monophasic system. Means only one phase always present in the solution. The second one, the component of solution cannot be easily separated by physical method. Third one, in solution, the solute particles 10 to the power minus 7 to 10 to the power minus 8 centimeter. Next one, certain properties of solution such as density, viscosity, surface tension, boiling point, melting point, freezing point, etc. vary with the composition of solution. Next property, you can write the property of solution or the properties of its component. The properties of the solution is the properties of its components. That is, you can say the component do not lose their properties when they form solution. That is, the component do not lose their properties when solution become formed. So such are the general characteristic for solution. If two components are present in the solution, known as binary solution. Similarly, if three components are present, called ternary solution. If four components are present, called quaternary solution. In two component system, the one part is called solute and the other part called what? Solvent. So we can write what? In two component system, that is solute plus solvent is equal to solution. That is one solute and one solvent. This type of solution is known as what? Binary solution. If solution is ternary, it means the solvent is fixed, but you can take two solutes. Such solution are called what? Ternary solution. In two component system, the component whose physical nature is similar to that of solution is called solvent, and the other part is called what? Solute. Suppose if we take NaCl solid plus water liquid gives NaCl solution. The phase of NaCl solution is what? Liquid. The component whose physical nature is similar to that of solution is called what? Solvent. And the other part called what? Solute. If we take CuSO4 solid plus 5H2O liquid gives CuSO4 5H2O solution. This is again solid. The component CuSO4 is similar to that of solution, then that part of it is called what? Solvent. And this is known as what? Solute. So this is a very interesting example. In this solution, water is treated like what? Solute. Suppose if we take ethyl alcohol liquid plus water liquid to form C2H5OH solution. This is also liquid. Here the physical nature of both component is similar to that of solution. Then a small part component is called solute and large part component called what? Solvent. Suppose if we take 10 milliliter, this 100 milliliter, this is used in excess, that's why it is called what? Solvent, and other part is called what? Solute. If the quantity of both components become equal in solution, then generally the component whose density is higher known as solvent and the other component is called what? Solute. So this is a way to predict in solution which part is known as solute and which one becomes solvent. Our next one is classification of solutions. Solution can be classified on the basis of either concentration or on the basis of its phase. So our first one, on the basis of concentration of solution. In this way, we can form different type of solution. First one, dilute solution. Second one, concentrated solution. Third one, saturated solution. Fourth one, supersaturated solution. And last, unsaturated. So different pattern of solution can form on the basis of concentration. Dilute solution means solute become lesser and solvent are always in excess. Concentrated solution means relatively large amount of solute dissolved in a small amount of solvent. Saturated solution means the maximum amount of solute in gram that can be dissolved in 100 gram of solvent. Supersaturated means a solution containing more amount of solute than that of required for saturation of a given amount of solvent at a particular temperature. Unsaturated solution means a solution containing less amount of solute than that required for saturation of a given amount of solvent at a particular temperature. Generally, we study dilute solution, or you can say saturated solution, in our solution chapter. Our next classification is on the basis of phase of solute and solvent. So we can write classification of solution on the basis of phase of solute and solvent. 9 types of solution you can form on the basis of phase. So we can write solute, solvent. Examples. First one, solid, liquid, gas. Here we can write solid, solid, solid. Example is what? Any alloy. That is, you can write brass. Here we can write amalgam of mercury. Means mixture of two metals. One metal is mercury, known as what? Amalgam. Solution of S2NP. This type of solution is known as what? Solid solution. Because total credit goes on solvent. Next, DEF. Solid, liquid, gas. Here we can write liquid, liquid, liquid. The example is sugar solution. Means sugar plus water. Liquid plus liquid means two miscible liquid. That is, for example, benzene plus tonic. Gas plus liquid, CO2 in water. At high pressure, CO2 dissolved in water. GHI. This type of solution is known as what? liquid solution. You know very well. Here solid, liquid, gas. Here we can write gas, gas, gas. Iodine vapor in air. Here we can write moist air, means gas containing some water vapor. Gas plus gas, mixture of dry air. This type of solution is known as what? Gaseous solutions. So in all 9 type of solution, we will revise only liquid pattern of solution, that is solid plus liquid, second one liquid plus liquid, third one gas plus liquid. So such pattern of solution, first we revise solid plus liquid solution. Our next heading is concentration terms, means method of expressing the concentration of solution, that is concentration terms. There are several ways to express the concentration of the solution. First one, percentage. Percentage can be written as in terms of W by W, or you can write W by V, or you can write V by V. It is said to be by mass, it is said to be by volume. The upper part is called what? Solute, and the lower part is called what? Solution. Second one, molality. It is represented by M. We can write what? Molality is equal to weight into 1000 divided by M dash into V. Third, molality is small m. Molality is equal to M dash into W. Fourth, mole fraction. X is equal to small n by small n plus capital. Mass fraction. Suppose X dash is equal to a small w plus capital W. ppm, W plus capital W into 10 to the power 6. ppb, W by W plus capital W into 10 to the power 9. And 8-1 you can write what? Normality, W into 1000 by A into B. So there are several ways to express the concentration of solution. In our molality, this term is known as what? Mass of solute. This is volume of solution in milliliter. M dash is equal to molar mass of solute. Here weight of solvent in gram. N is equal to number of moles of solute. Capital N is equal to number of moles of solvent. Here a small w, mass of solute. This one, mass of solvent. Here E is equal to what? Equivalent mass of solute. What is equivalent mass? E is equal to molar mass divided by N factor. So there are several ways to express the concentration of the solution. Next, I will revise you some formulas which are very useful to solving numerical problems. Note. First one, V1N1 is equal to V2N2. This is known as what? Normality equation. Second one, V1M1 is equal to V2M2, known as molality equation. This equation is only applicable when same solution become diluted. But our normality equation is applicable everywhere. Means what? In first equation you can change solute and solvent, but in second one solute and solvent become what? Fixed. You must be added excess solvent for fixed solute. Therefore, we can write only applicable when same solute become diluted. Third one, suppose A plus B plus C form mixture. Here, acid 1, acid 2, base. We can write what? Suppose volume V1 normality N1, volume V2 normality N2, volume V3 normality N3. We can write V1 N1 plus V2 N2 is equal to what? V3 N3. Fourth, solute plus solvent to form solution. Here V1 N1, V2 N2. Here we can write V mixture, N2N mixture. So V1 N1 plus V2 N2 is equal to what? V mixture into N mixture. So these are the way to find out the strength of solution. If a strength of mixture is unknown, then we can predict with the help of our equation number what? 4. Next, I will revise you colligative properties. Such properties which depends upon the number of solute particles, not their nature. This property is good hold when our solution become diluted, and solute become generally non-volatile and non-electrolyte in nature. Suppose if we consider a solution that is solute plus solvent to form a solution, solute always exists in solid state and liquid solvent means solid plus liquid solution always considered in our colligative properties. 4 colligative properties are well known. First one, P naught S, Ps by P naught S, N by capital N. This is known as what? Relative lowering of vapor pressure. Second one, delta TB is equal to Kb into M. This one is known as elevation of boiling point. Third one, delta TF is equal to Kf into M. This is known as what? Depression of freezing point. And the last one, pi is equal to C into R into T. This is known as what? Osmotic pressure. Where terms has got its usual meaning. If we multiply I is said to be what? Vent half factor. When our solute either dissociate or associate in solution. You always know the value of Kb water is fixed. That is said to be what? 0.512 Kelvin kg per mole. And Kf for water is what? 1.86 Kelvin kg per mole. So always remember such numerical value for Kb and Kf for water. The target is what? For such expression we can determine the molar mass of solute when solute become non-volatile and non-electrolyte in nature. If solute either dissociate and associate in nature, then vent half factor become applicable. So our colligative property become changeable. That is P naught S minus Ps divided by P naught S I into N. This one. This I is said to be what? Vent half factor. First you determine vent half factor. If other terms are given and molar mass of solute is unknown, then we can find out the molar mass of solute. In next lecture, we will discuss liquid plus liquid mixture. It means solute is liquid and solvent is also liquid. That is, you can say miscible of two liquid, that is miscibility. So in next lecture, we will study miscibility of two liquids. Thank you.